my dear student. Good evening to all of you. Today I am going to demonstrate a short video on topic that is known as gravitation. My name is Mintu Pal over here. So let's start our discussion. As we know that gravitation is a kind of force. So from the first law of Newton, we know that an object remains in its state of rest or of in motion in a straight line until and unless if we compelled by a net force acting on it to change its state. That means any two objects like A or B, two objects are there. Until and unless if I am not or we are not acting or compelled any net force acting on that object, these two objects are always remains in its state of rest or with an uniform motion. In ancient world, Galileo Galilei first understood or probably understood that the things fall downwards because they feel a net force on them. They feel a net force on them. That net force is rather discovered by Isaac Newton and named that force is a gravitational force. And Newton says that any two particles in this universe attract with each other with a certain kind of force which is called the force of gravitation or gravitational force. According to him, if A may be known as gravitational force and this gravitational force is then rather inversely square proportional with the distance between the object and proportional to the multiplication value of the mass of this object. And if we using both this multiplication into a single term, we are approaching a new constant is known as capital G, and the total equation is expressed as G m1 m2 by d square or r square, where m1 and m2 are the mass of these two objects and d be the distance between them, up to which distance they can attract each other or up to which distance the earth crust attract that object which is easily thrown to the upward side. That means the force of gravitation exerted by earth is called gravity, but the force which is actually present between any two particles is known as gravitational force, but the force of gravitation that is exerted by earth is known or is called gravity. Okay, and this gravitation is demonstrated by Sir Isaac Newton. So F is equals to G m1 m2 by d square, where G is known as gravitational constant or universal gravitational constant. And if we put that the value of mass of both the object are same to unity and the distance between them is 1 unit, then the force applied on that object is equals to the value of gravitational constant. Okay, and the unit of this gravitational constant G is expressed as F into d square by m1 into m2. So the unit of force is Newton meter square, and Newton and the distance is meter square, and this is expressed as kgs into kgs. That makes Newton meter square divided by kg square, that is the unit of gravitation in SI system, and in CGS system it is dyne, it is centimeter square, and it is expressed as gram square. So these two are the unit of capital G, and the capital G value is a fixed value because it is known as constant. Henry Cavendish first expressed that constant and find out its value. Henry Cavendish first sensitively calculate this value, and after determining this value he told that the value of gravitation is 6.6 into 10 to the power minus 11 Newton meter square kg square. Okay, and it is always a scalar quantity. It has only value, no magnitude present over here. Thank you.